Welcome to Shift Change, the Idaho Manufacturing Podcast. Over the course of about 20 minutes, we bring you conversations on AI, tech, and the future of Idaho manufacturing. Funding for this program comes from Total Care IT, your Idaho-based IT and cybersecurity partner for manufacturers.
What if I told you that in factories today, machines are already predicting their own breakdowns? Long before they actually happen.
It sounds like science fiction, doesn't it?
It really does. And that products are being made with such pinpoint precision, they're almost flawless.
Mm-hmm.
And that entire global supply chains are basically running themselves, anticipating disruptions before we even see them coming.
Well, that's the thing. It isn't science fiction anymore.
Exactly. This is the reality that artificial intelligence is actively building in manufacturing right now. Okay, let's unpack this. Welcome to the deep dive.
Great to be here.
You've shared some really incredible sources detailing how AI is revolutionizing, everything, from the factory floor to global supply chains.
Right. But they also highlight some, pretty crucial challenges that come with this powerful tech.
Definitely. So our mission today is to dive deep into these advancements, show you how they're being applied in the real world, and explore what it all means, for human-machine collaboration and building a truly smarter future.
It's fascinating stuff.
And we're seeing AI integrated at every level. It's transforming industries you might not even expect.
Yeah, what's really fascinating here is how AI is moving beyond just simple automation. It's enabling intelligent cooperation.
Intelligent cooperation.
Yeah.
Like machines and people working together.
Exactly. It's solving complex problems in real time, changing not just what we make, but fundamentally how we make it. It's fostering this new kind of intelligent ecosystem.
So when we talk about AI being a game changer for manufacturing, what's the core shift? Is it just about speed, or is it deeper than that?
Oh, it's definitely more profound. At its heart, AI-driven robotics fulfills three really essential objectives.
Okay.
It addresses labor challenges, creates significantly safer workspaces, and it minimizes resource consumption. Less waste.
Safer, less waste.
But the real insight, I think, is that it's a shortcut to being proactive instead of just reactive.
Proactive. How so?
Well, we're moving away from traditional scheduled maintenance or, worse, waiting for something to break down.
Right. The reactive approach. Fix it after it breaks.
Exactly. We're moving to a world where AI predicts and helps us avoid those failures before they ever disrupt production.
So it's not just about making things faster. It's about making them better, safer, and with less waste. It's like redefining what's possible on the factory floor.
Precisely.
That's a massive shift in mindset for a whole industry.
It really is. Yeah. And if we connect this to the bigger picture, it's about making industrial processes far more efficient and resilient.
Resilient. That's key.
Yeah. AI allows these systems to adapt to variable environmental settings through really sophisticated automated learning and decision engine programs. It makes the entire system just more adaptive and robust when things get unpredictable.
And that vision, this more efficient, resilient future, it's not just theoretical, right? We're seeing it happen now.
Oh, absolutely. It's making real-world impacts already.
So what's one of the most compelling applications you found in the sources, something that really shows this revolution in action?
Well, one of the earliest and I think most impactful applications is predictive maintenance. PDM, they call it.
PDM, okay.
This is where AI analyzes just vast amounts of sensor data, think vibration, temperature, acoustic signals, electrical current, even spindle speed.
Wow, all that data.
All of it from machines. And it uses that data to forecast equipment degradation or, outright failure.
And this isn't just a lab experiment.
No. This is happening across over 150 machines with more than 120,000 machine hours recorded. It's predicting everything from spindle motor failure to tool wear, cooling system problems.
So it's really specific.
Very specific. It significantly enhances traditional condition-based maintenance, CBM, by providing continuous real-time monitoring.
And there are some really great examples of the actual benefits, right? I was reading about this mid-size electronics factory. They used AI-powered PDM to shorten a soldering process by just 50 seconds. Sounds tiny.
Doesn't sound like much, does it?
But it saved 18% electricity per shift. That added up to over 90,000 kilowatt hours saved annually.
That's huge.
And cut 15 metric tons of carbon emissions. And even railroads are using AI and sensors now, cutting emergency repairs by 35%, delays by 40%.
It's a staggering domino effect, isn't it?
Yeah.
From what seems like a minor change.
Absolutely.
And it goes beyond maintenance. AI is dramatically improving quality control and process optimization, too.
Okay, how does that work?
Well, AI-controlled vision systems, for instance, they ensure really precise product examination quality throughout the production line.
So like robot eyes checking everything.
Essentially, yeah. And by automating these incredibly repetitive tasks and analyzing massive data sets, AI improves accuracy and drastically reduces human error in detecting defects.
All right, so no more squinting at tiny components hoping you don't miss a hairline crack.
Exactly.
That sounds like a real qualitative leap in reliability. I imagine that has huge downstream benefits for everyone.
You're right. That consistency is a huge advantage. We see companies like Airbus. They increased assembly line accuracy by 30% using computer vision to spot misalignments. Yeah. And Boeing saw a 62.5% reduction in assembly defects.
Wow.
Procter & Gamble, P&G, they reduced downtime by 30% and increased efficiency by 20% just by optimizing production lines with AI.
Incredible numbers.
And what's more, AI can dynamically adjust production schedules, reallocate resources based on demand fluctuations. It helps ensure seamless operations. General Electric, GE does this for efficient material and labor use.
Those are massive gains. Quality, efficiency.
Yeah.
But okay, once the products are perfect, you still need to get them where they need to go. How's AI tackling the huge challenge of global supply chains?
Right, the logistics piece. Well, AI is absolutely streamlining operations there, forecasting demand, managing stock levels, improving logistics.
How does it forecast disruptions? That sounds tricky.
It uses machine learning algorithms to look for patterns that might indicate potential supply chain interruptions. And deep learning can identify really intricate patterns for emerging risks, things humans might miss.
Emerging risks, like what?
Well, what's fascinating is how natural language processing, NLP,
Understanding human language.
right, NLP tools analyze global news, social media, trying to foresee political instability in supplier nations, for example.
Wow, so it's reading the news to predict supply chain problems?
In a way, yes. It allows companies to make proactive adjustments before a crisis actually hits.
I was reading about Amazon's use of AI, and it's just mind-boggling.
They're definitely at the forefront.
These Robin arms and Proteus robots optimizing their supply chains, increasing speed, lowering costs.
Billions of packages handled by Robin arms alone.
And generative AI, helping predict product placement for new items to cut travel distance, boost sustainability. Makes you wonder about the scale of intelligent automation happening, behind the scenes.
Absolutely. And the key insight with Amazon, I think, is that AI is integrated at every single touch point.
Every touch point.
Yeah. Neural networks, for example, help them recommend hyper-personalized products to you. They even assist sellers in generating product listings and images. And it extends right back to the factory floor in how humans and machines now interact. We're moving towards what some sources call intelligent cooperation or co-working.
Intelligent cooperation again.
Yes. AI-driven robots are learning from human operations, adapting to dynamic environments, constantly improving efficiency.
So they're not just following orders, they're learning, adapting, evolving alongside us.
That's the idea. It's a huge step beyond simple automation.
Where is this intelligent cooperation really taking shape? What does it look like?
Well, you have these robots working right alongside humans. They're executing the repetitive or physically challenging or maybe risky procedures.
Okay, so improving efficiency and safety.
Exactly. Better efficiency, significantly improved safety levels. We see it in healthcare, where humanoid robots monitor senior patients' emotions to provide social interaction, combat loneliness.
Really, monitoring emotions.
Yeah. And of course, the Da Vinci surgical system is already widely used, an AI-assisted robotic system.
Right, in surgery.
And in a more surprising example, maybe, Autovol in Nampa, Idaho. They're using robots to build affordable housing.
Building houses with robots.
Yep. Reducing man-hours per module by at least 50%. And they're empowering their floor employees, too, giving them opportunities to share ideas.
That's amazing. Affordable housing.
And the future vision. It even includes robots assisting in intellectual and imaginative activities, things like design development, research, creative industry analysis.
That really changes how we even think about what technology can do. It's not just automation, it's augmentation.
Well put, augmenting human potential.
Speaking of intellectual activities, how are the newer AI technologies fitting in, like generative AI, large language models, LLMs?
Right, LLMs. They're doing more than just the common enterprise tasks you might think of. In manufacturing, they're being used to summarize long, complex reports from machines or sensors.
Summarizing machine data.
Yeah, automatically identifying trends or anomalies that might be buried in the numbers. They also perform powerful pattern recognition in text for sentiment analysis in customer support, for example, or text classification.
Okay, that makes sense.
But what's really powerful is their role as programming assistants.
Programming assistants.
Yes. They enable people without deep AI or statistics background to create things like fault detection algorithms, just using simple natural language prompts.
So you can just tell it what you want it to look for.
Essentially, yes. And they can generate custom dashboards, too. Plus, they can extract information from complex technical blueprints, like CML diagrams, chemical markup language diagrams.
Wow.
And work with technical manuals,
Yeah.
saving engineers just a ton of time and really democratizing access to complex data.
That's fascinating. It really
Yeah.
sounds like AI isn't just one tool. It's an entire intelligent ecosystem touching every single part of manufacturing.
Exactly, from the tiniest component inspection right up to broad strategic planning.
Which raises a question, I guess. How is all this actually enabled? What are the technologies underneath it all? What's the backbone?
That's a great point. It's like looking into the engine room of one of these smart factories.
Right. It's not just the AI software itself, but the whole infrastructure. What's powering this revolution?
Well, a critical component is sensor networks and the Internet of Things, or IoT.
IoT.
Continuous condition monitoring that's enabled by these IoT sensors. Tiny smart devices collecting real-time data, vibration, pressure, acoustic signals, load current, temperature, humidity, even dissolved gas concentrations in some cases.
Tiny sensors everywhere.
Often forming what we call wireless sensor networks, or WSNs. Basically, a web of interconnected sensors monitoring multiple points across the whole facility without needing miles and miles of cables.
So it's this constant, dense stream of information coming in, but that must generate absolutely massive amounts of data. How do you handle all that?
You're absolutely right. The data volumes are exponential, and that's where cloud and edge computing come into play.
Cloud and edge, okay.
Cloud platforms, AWS, Google Cloud, Microsoft Azure, they handle the really heavy lifting. AI model training, large-scale data storage.
The big number crunching.
Exactly. But for real-time applications where decisions need to happen in milliseconds.
Like on the factory floor itself.
Right. That's where edge computing comes in. It processes data near the source, maybe directly on the device or on a local edge server.
Closer to the action.
Exactly. It drastically reduces latency, which is critical for industrial automation where you need instant responses.
That makes totally sense for, like, a robot arm needing to stop instantly. But what about planning? Creating virtual testing grounds, optimizing factory layouts before you build them.
For that, we use digital twins.
Digital twins, I've heard that term. So virtual replica.
Precisely. Virtual replicas of machines or entire factories or even complex supply chains. There are examples for power transformers, for instance. They simulate real-time behavior.
So it's like having a perfect, constantly updated video game of your factory, where you can test things out.
That's a good analogy. It's a living, breathing digital replica. With power transformers, for example, you can simulate years of wear and tear in just hours. Spot potential failures long before they happen in the real world.
All in a risk-free virtual environment.
Exactly.
Okay, so you have sensors collecting data, edge and cloud processing it, digital twins simulating it. How do you actually move all that data around efficiently?
Good question. That requires robust data pipelines. Technologies like Apache Kafka and NiFi. Think of them as super fast data highways, aggregating data from all those diverse IoT devices.
Data highways, okay.
Then advanced tools like Apache Spark and Flume act like powerful processing plants. They analyze massive amounts of sensor data in real time, much, much faster than older systems could.
And once it's all processed,
Yeah.
how do the engineers, the managers, actually see it, understand it, turn it into something actionable?
Right, translating data into insight. That's where interactive, browser-based visualization tools and dashboards come in.
Like Power BI, Tableau, those kinds of things.
Exactly. Power BI, Tableau, Amazon QuickSight, Grafana, they translate all that complex data into clear, actionable insights, showing real-time machine status, production counts, material movement, historical trends.
Making the complex understandable.
Yes, and making it actionable for decision makers right there on the factory floor. It often helps overcome the limitations of older legacy systems that couldn't provide that real-time visibility.
So it's this massive interplay, isn't it? Hardware, software, Tiny sensors, cloud supercomputers,
Yeah.
all working together to create these incredibly intelligent, responsive systems.
It really is. The factory itself is becoming almost like a giant self-optimizing organism.
Wow.
And like we said, it's not just abstract possibilities. We have incredible real-world examples. Should we dive into some specific case studies?
Absolutely. I'm eager to hear where these technologies are making the biggest splash.
Okay, well, let's start with that compelling example in affordable housing construction we mentioned. Autovol in Idaho.
Right, using robots to build houses.
It's exactly increasing efficiency, precision. Their goal is to cut man-hours per module by at least 50%, directly using advanced tech to address a fundamental societal need.
That's a fantastic example, technology meeting social impact. What about the more, traditional manufacturing giants? Where are they seeing concrete gains?
Well, Siemens, for example, uses AI-driven analytics for predictive maintenance. They've cut downtime by 20%, optimized energy use.
20% downtime reduction. That's significant.
It is. Airbus uses AI to optimize composite material manufacturing, their assembly lines, increasing accuracy by that impressive 30%.
Right.
And you see this pattern across the industry. General Motors, GM, saw a 25% reduction in unplanned downtime. Boeing, we mentioned their 62.5% reduction in assembly defects, plus optimized inventory.
It's clear these companies are finding massive, measurable improvements, real ROI.
Definitely.
You mentioned Amazon earlier, too, and how they're handling packages and logistics. But they're also investing heavily in their people to adapt, aren't they?
Absolutely, and that's a crucial point. Amazon isn't just deploying generative AI with its Robin arms and Proteus robots for faster, more sustainable deliveries. They're also investing over $1.2 billion to upskill more than 300,000 of their employees.
Wow, over $1 billion.
Yeah, it really recognizes that human talent needs to evolve right alongside the technology. It's not just about replacing people.
That's good to hear. And in sectors where precision and reliability are just absolutely paramount, like healthcare, pharma, AI is making inroads there, too.
Oh, definitely. Novartis uses IoT sensors and AI algorithms for predictive maintenance in drug manufacturing, significantly decreasing unplanned equipment downtime.
Which is critical when you're making medicine.
Absolutely. Pfizer uses AI-driven vision inspection systems to cut packaging errors, increase throughput, and they use predictive analytics for vaccine manufacturing.
Makes sense.
Boehringer Ingelheim also uses AI vision inspection for packaging defect detection, ensuring product integrity, high-stakes stuff.
It's really clear AI is reaching far beyond just the typical factory floor. I even heard about some fascinating uses in agriculture and material science.
Indeed. There are University of Idaho students applying AI to analyze millions of data points, from sensors in vineyards, forests, trying to optimize crop varietals, forest productivity.
Analyzing vineyards with AI.
Yeah. And in material science, AI is being used in stress corrosion cracking research SCC, which predicts failure points in materials.
Predicting when metal will crack under stress.
Essentially. It also helps optimize additive manufacturing. That's 3D printing parameters. And even design new alloys with improved resistance.
Designing new materials.
Yes. For example, AM alloys optimized by AI show a 15% improvement in SCC resistance. Early SCC detection is up by 35%. It's literally helping us invent new materials and understand their limits better.
These aren't just hypotheticals then. Real companies, real institutions, making massive strides with AI, showing clear, measurable improvements across incredibly diverse sectors.
It's truly pervasive.
Yeah.
Which highlights the immense transformative potential.
Yeah.
But this power also brings a unique set of challenges, things we really have to address responsibly.
That's a crucial point. As powerful as AI is, it's certainly not a silver bullet, is it?
Not at all.
What are some of the biggest hurdles manufacturers face when they try to adopt these advanced technologies?
Well, a major one is simply the high costs and the technical complexities involved.
A price tag.
Exactly. There's a significant upfront investment needed. Infrastructure, hardware, software, integration. It can often exceed $500,000 even for smaller manufacturers.
Oof, that's a barrier.
It is. And then there's integrating AI and IoT with existing legacy systems, old SQL-based ERP platforms.
Stuff that wasn't built for this.
Right. They often lack compatibility, lack real-time capabilities, and just ensuring data quality, standardization, interoperability across all these different sources, that remains a significant hurdle, getting clean data.
So it's not just plug and play. A lot of foundational work, significant expense. What about the people, the workforce? How are they adapting?
That's another critical area. Workforce adaptation and the broader societal impact. Public fears about job displacement. They definitely persist.
Robots taking our jobs fear.
Yeah. And some research does suggest each robot in manufacturing replaces about 3 workers, so it's not unfounded. Plus, there's a real shortage of skilled people in data science, machine learning, advanced analytics.
The skills gap.
Exactly. And frankly, you often encounter resistance to change among employees who are just used to the traditional ways of working.
Understandable, I guess.
It really highlights the need for extensive workforce reskilling, interdisciplinary collaboration, preparing people for new roles, not just replacing the old ones.
Those are very real human concerns that need careful management. Beyond the practicalities of cost and labor, there are also big ethical questions, regulatory considerations, especially as we talk about this idea of Industry 5.0.
Precisely. These are thorny issues. One challenge is the black box problem.
Where you don't know how the AI made its decision.
Exactly. The decision-making process can be opaque, which hinders transparency, makes auditing difficult.
Right.
Then there's bias and fairness. AI algorithms can, unfortunately, propagate or even amplify biases present in their historical training data.
So biased data in, biased decisions out.
Potentially, yes.
Yeah.
Leading to inaccurate predictions or discriminatory practices. Addressing this is a fundamental ethical imperative. It requires representative data sets, regular audits, ensuring fair outcome.
And with all these interconnected devices, all this data flying around, privacy and security must be huge concerns.
Absolutely enormous. These AI IoT systems generate vast amounts of sensitive data. Product designs, employee information, patient data in healthcare contexts.
Right.
All of that requires really robust cybersecurity measures, encryption, firewalls, advanced threat detection. You need it all to prevent cyber attacks.
Like what kind of attacks?
Things like denial of service, DOS attacks that try to shut systems down, malware, man-in-the-middle intrusions where attackers intercept communications.
Scary stuff.
It is. And you also need strong security to ensure compliance with regulations like GDPR in Europe or ETA for healthcare data in the U.S.
So, okay, if something does go wrong, especially with an autonomous system, a robot making a decision, who's accountable? Who's liable?
That is a really thorny issue, and it's something the sources emphasize needs urgent development. We need clear policies, clear regulatory guidelines to define responsibility.
It's not obvious.
Not at all. After an accident involving, say, robot-assisted medical care or a self-driving vehicle, liability might be shared between the manufacturer, the programmer, the end user. It's complex.
It needs international cooperation, too, I imagine.
Definitely. AI and robotics development is global. We need international collaboration to standardize policies, best practices.
Yeah.
You see efforts like the U.S. and China working on AI ethics policies.
And this fits into that Industry 5.0 idea.
Yes. Industry 5.0 explicitly emphasizes human-centered design, sustainability, resilience. And ensuring AI trustworthiness is a core part of that vision.
So, wow. As powerful, as transformative as AI is, it's definitely not a silver bullet.
Far from it.
There are significant hurdles, technical, financial, human, and some really deep questions we need to answer about building and using these systems responsibly.
Which just highlights the critical importance of a holistic approach. Ethical, collaborative. This isn't just about cool tech progress. It's about responsible innovation that actually creates societal value.
What a journey it's been today, really. We've seen how AI is genuinely transforming manufacturing, driving efficiency, safety, innovation across such diverse industries.
Predicting machine failures, optimizing supply chains.
Building houses with robots, even designing new materials. It's incredible.
It is.
But we've also touched on those critical challenges, the high costs, the technical hurdles.
The need for a skilled, adaptable workforce.
And those complex ethical and regulatory questions around AI trustworthiness. Very important.
Crucial.
The future of manufacturing, this Industry 5.0 vision, it sounds like one where AI, IoT, robotics are all seamlessly integrated, creating adaptive, efficient, sustainable, smart factories.
That's the goal. And it's a vision that explicitly prioritizes human-machine collaboration. Ensuring technology serves human needs, promotes sustainability, builds resilience against, unforeseen challenges.
So here's a final thought to leave you with. As these AI-powered robots continue to get more autonomous, capable of making decisions with real-world effects, how do we ensure that while they work like humans, they also embody the best of human values?
That's the question, isn't it? Fairness, transparency, accountability.
How do we build those values in? And maybe, looking forward, what new forms of human ingenuity will be sparked by this advanced collaboration? What problems, previously unsolvable, might we tackle together, maybe unleashing a whole new era of innovation?
Thanks for joining us on today's episode of Shift Change. To learn more about using AI in your manufacturing business, reach out to Total Care IT, your Idaho-based IT and cybersecurity partner for manufacturers.